Okay, so so far we have seen this class node. So in class node, we have one additional part is this previous node, and this part is as it is. Now, when we try to print the double linked list, we don't need to do any changes in case of printing the list. We can simply print the element using the normal code. Okay, so this was the same code for normal linked list also. Now this is the same code for double linked list also, right? What additional thing we can do is in case of normal linked list, once we move forward, we cannot come back to the previous element, right? But in case of the double linked list, once we move forward with the previous element, we can move back also, right? So how so in this case, what we can do is um, here um, like something what we can do like this we can represent in this case. Um, yes, this we can represent. Um, how to present it is reversing towards backside. So both case we can do. Um, I need to search that sign how we can represent because it will work in both directions, right? So we don't need to here this will show only one direction only. So we have to add something like which can refer the previous direction as well. Okay, let's see. So here what we can do, we can do something else like if Cn is equal to Nd, then we have to then what we have to print is print um first of all we'll print null over here, null value, then like this, then Cn dot data. Okay, and rest else part we can do it like this. So now for the first element, it will print like this. For rest elements, it will print like this. Okay, now let's first create the list. Then only we'll be able to see how these things are working. Okay, we'll create this. So to create the initial linked list, what we can do is we can just give a normal numbers like node node one is equal to we'll say take the small node one is equal to node of let's say I have taken 23, then node two is equal to node of let's say 34, and then node three is equal to node of 55 I have taken, and node four is equal to node of 51. Okay, and now what I'll do is just node one dot next is equal to node two node two dot next is equal to node three mm, node three dot next is equal to node four. This is what we have defined the next node. Now we have to define the previous node as well. So previous node will start from node 2. node 2 dot previous is equal to node 1, then node 3 dot previous is equal to node 2, and node 4 dot previous is equal to node, and let's say this is 3. Okay, so this is how we can define, and then we can call this print linked list. So I'm just calling print underscore linked list, and I'm giving node 1 over here, and here instead of node I'm giving nd. Okay, so let's see if this works or not. Okay. Okay. Here, next thing I have to do is comma and is and is equal to something like this. Can you see this?
Uh,
Hmm?
yeah,
Can you understand this?
yes,
So this is what is our linked list. We have doubly linked list we have created. Double linked list we have already created now. So if at any point of time you want to see anything like a node, we have print node 2 of previous if you want to print. Oh, sorry, dot previous, node 2 dot previous. So individually you node 2 dot previous. अच्छा previous तो address ही दिखाएगा ना, ठीक है. Previous dot and I'm taking this data. Okay, so node 2 is this. This is node 2. Previous of this is this, and data part of it is this 23. Okay, if you print node 3 of previous, so you can see this is 34. And if I see the next of this, next of this, so you can see here this is 34, this is 51. So this is 55 previous is this, and 55 next is this. Okay,
yeah,
understood how this all is working?
yeah,
Okay, very easy. Just you have the extra node of this previous part. So if at any point of time, if you reach at some place and you want to print, suppose the entire list in the reverse order, so you can print the entire list in reverse order also. So when you have to print the entire list in reverse order, so reverse print I am just taking, and here also I have just this code only. So to print in reverse order, first of all, what you have to do, you have to travel the entire list till last. So I'll make a different function for travel travel linked list nd, and here I'll do nd if cn is equal to nd, and while cn of next not equal to null, not equal to none. This is what we did in last also, and it will do cn is equal to cn dot next. So it will move from first node to last node by this code. Okay,
yeah,
so and then it will here return cn, and we'll call this travel linked list function over here. So what we'll do is we'll do travel travel linked list um, current node is equal to, and we'll travel travel of ND. Okay. And now what we'll do is while mm, while current node, and now we'll print like print mm, current node dot data comma end is equal to, and this I'm just printing in the reverse manner, and here just I'll do um, cn is equal, sorry, current node is equal to current node dot next, and here just print null. Okay, so now this will print the list in reverse order, and I'll call this here in reverse print, rev print nd. So rev print rev print, and here node one I'll pass. Okay, so let's execute this. Travel df. Okay, the colon is to be placed over here. Yes, colon will be placed here. Why it is hanging so much? Could not hang this much. No, not this. Here. Yes. Now it will execute. So travel not defined. Okay, travel linked list underscore linked list. Yes. 50. No, only it is printing 51. Okay, sorry. Here it has to go previous, not next, because it is going towards the reverse side, no? So it will go on previous. So it will print. Now you can see it is printing in reverse order.
Yeah.
Okay, so this is the way you can print your list in from both sides. So just once you understand the concept, it will be easy for you. Are you understanding these concepts?
Yeah.
Okay, so now next what we are going to do, now let's do the same operations that we did for the normal linked list. So for the normal linked list, suppose we are going to add an element. Okay, so add element can be at the starting also, it can be at somewhere middle, and it can be at last also. So you have to figure out where it has it is going to insert the value. Okay, so let's say if it is going to insert a new value at the start. Okay, so insert value at the start. Okay, so now it will call a function. So we'll again define. So it becomes suitable when you define it with function. So define insert start, and here also will take it as node one, and here we'll take cn is equal to node one. Okay, and then we'll ask to insert a new value to be inserted. So val is equal to integer input, enter enter the number to be inserted. Okay, then now we have taken the value. We'll take a new node is equal to node of val. Okay, so it will insert a new value. Now, since we are going to start, so the current node which is here, which is at this place, this will be the second element now, right? So new underscore node of next will be CN, or we can even write it node one also at this place. Okay, understood?
Yeah.
And now, since this will be the starting element, so now node one of previous will be this element, correct? So node one dot previous is equal to new underscore node. Okay. Now the node is connected with the previous, and this is, and now next thing is the previous of this new node. Since this is going to be the first node now, so previous of this new node will be blank, will be null. So we are not storing anything in this new node. And finally, what we have to do is we have to move this node one to new node. Right now, your list is starting from node one. So if you print in the same way, it will. Let's just print over here. Print linked list and node um, with node one I am printing over here. So what it will do is it will print the list in the same way it is. Okay, so I'll just call insert start and node one is being passed. I'm changing this name ND, right? Otherwise, it may create some ambiguity sometime in ND. Okay, and now I am executing this. So here I am inserting a new node value as 222, let's suppose, right? So still you can see here, since this node one is at this place only, so that's why the new number that has been inserted, it is not printing. So what we have to do, we have to move this new node, this ND to this new node. Okay. So we have what we have to do is ND is equal to new underscore node. Okay. Now when
Okay.
you will execute this, so I'm inserting new value as 222. So now you can see this is 222 starting from 222. Okay,
Okay.
clear?
Yeah.
Okay, now the second function will make is insert a value at position. Okay, at some position we have to insert. So what we'll do is again define insert POS, and I'm taking ND over here. And same thing, ND is equal CN is equal to ND. This we are going to do every time. Whatever the operation we are doing, we have the contact point, and we'll make them make it as at some variable. Okay, enter the number to be inserted. Okay, and here we'll close this, and we'll take again a new node is equal to node of val. Okay, this we have taken. Now, um, this has to be inserted at some position, so we'll ask the position also here itself. So POS is equal to integer input, and we'll ask enter the position where element needs to be inserted. Okay, and we'll close this. So by this we'll get the position. Now the same thing we have to do. So what we have to do is we again suppose it is asking me to insert a new element at third position. So right now in your list, your third position is this between 30, 23, and 24. This is the third position. So 34 will move forward and a new element will come at the place of 34. Okay, so to reach till 34, if you are using the normal linked list, you need to stop at 23, insert second element. But in case of double linked list, since you have the option to go to the previous element also, then we can come up to this position also. Okay,
Yeah.
so this is a small difference. So let's see what we'll do is while, so we'll take a count. Count will start from 1 and while count is less than or equal to POS. Okay, what it will do is CN is equal to CN dot next and count plus is equal to 1. So it will keep on increasing count. And now let's suppose it has reached to this position, right? This is the place where new element will come and this element will move further. Okay, now let me open my designer part. Okay, so why it is hanging so much? Let me show that. Mm, okay, can you see the screen?
Yeah.
Is this white space visible for you?
Uh, I can see the canvas.
My mouse is moving because I cannot see this at some other screen. My mouse is moving, correct?
No,
You cannot see my mouse moving.
no, I can just see the white screen.
Can you see this that I'm drawing?
Uh, yes, now I can see.
So now you have let me clear this. Okay, now you have this list. So here. So this is the list that we have. Okay, and here this is the second element. Okay, and now between this, a new element has to come. Okay, between this, a new element has to come. So this element is somewhat like this. Give me a second, I'm getting some call. No, sure, I'll call him later. So now here I have to insert. Right now connection is like I don't need to consider this as of now because they are connecting to the other element. Here I have to connect this element. Okay, right now what condition is this is referring to this and this one is referring to this. Okay, so what we have to do is now this one should refer this one should refer this, and this one means the next of this. So this suppose right now we are at this position. Let's suppose we are at this position. So what is this? This is x of previous. Okay, this
Yeah,
is x of It is not writing properly. This is the x of previous. Okay. So what we have to do? Okay. Am I audible?
Yeah.
So now, after when this new element will insert it, so this next will be referring to this one. Okay, and this will be referring to this place. Okay, and previous of this will be referring to this element, and previous of this element will be referring to this. This connection will somewhat create like this. Okay. So there will be four connection exchange will be there. So right now this is connected to this. So this connection will break. This connection will break, and this will be connected with this element. Okay, this is the new element. Okay, this is the new element. No, let me open something else. This whiteboard is not working properly as per my expectation. Like, okay.
Can't see your
Is
screen.
sorry.
I can't see your screen. Oh, it's yeah, I can see it now.
Okay.
Yeah.
Right now your list is like this. Now, let's see a new element has come. Okay. This is a new element here. The value that we are going to insert is already stored. Okay. This value is already stored. Now, what we have to do is we have to connect this element. So after connection, what should be there? This link will break, and it will be referring to this element. Okay, then this will be broken, and this will refer to this, and this will refer to this, and it it this will refer to this place. Okay,
Okay.
connection will be created like this. Okay, so what will be the ordering of creating the connection? So ordering of creating connection is that first of all, I have to attach this element. I have to attach this element with these both, right? So the next of the next of this means this part will have the address of this. Okay, so where is the address of this? Address of this is at here. So what will happen? So suppose this is new node. So new of next is equal to, it will be this will be suppose this is x. So this will be x of previous of next. Okay. So this is x, this is x previous, right?
Yeah.
Understood? This is x previous, and this place is uh, x of previous of next. So address of this x of previous of next is having the address of x. So this will be connected like this. Okay. And new dot previous will have the address of x of next. Okay, so let me show you how we do in this code. In the code, it is here. Okay, so here now I am inserting an element. So now this has current node has reached to at its place. So what will now what we'll do is we have the current node now, and we have the new node also, right? So now what we'll do is new underscore node of next will be it will be connected to CN. Okay. Then new underscore node of previous. It will be connected to CN dot previous. Current node of previous will be attached with this, right?
Yeah.
Now, current node of previous of next will be new node. Okay.
Yeah.
And current node of previous will be new node. Okay, so these four place exchanges will take place over here. Can you imagine this in your mind?
Yes.
Understood.
Yeah.
So if you're able to imagine, then after this, we'll just print linked list and ND will pass over here. And then we'll call insert POS, insert POS, and we'll pass node one over here. Okay, so now let's suppose we have this 34 and 55. In between this, we have to give a new element. So this is going to be the fourth position. So at fourth position, we have to insert a new element. Okay, so I'll just run this. Uh, insert. Okay. So here at fourth position, we have to insert a new element as, let's say, 44. Okay, so what is this now? CN. Hmm. What is this? None type object has no attribute. Previous. CN dot previous. Why it is getting given this? Current node is reached. Okay, let's see what is the value of current node. CN dot data. Let's see what is the value. Let's say 4 and 44. Oh, why it is showing this? Why it is giving CN dot CN is assigned over here, and this is with ND. Okay, no issue with this. Position we have taken, value we have taken, new node. Well, this is also done. Now why it is giving this error? CN dot data error. Why it is giving? Everything is fine. Why it is giving this? It is there. Why it is saying that there is no attribute like this called data?
Maybe try running everything again. It's not safe.
Hmm.
Try running each block again. So maybe
Data was work fine with everything, and here it is not working. How? Okay, let's see and lot. And it say that previous is not there. It is there, and it was working fine. Can it say okay for 44? It is printing very clear till here. After that means it is going till here. Everything it is going correct. Okay. Okay. Let's see now. Print LL and node one I am taking, and I'm printing this. So we have 444. Here also it is working fine. Let's see if I print with C in. So 444. Okay, something is happening in this portion. What is happening? CN has lost its place over here. CN is initialized over here. Okay, okay, that's fine. Um, no, this should not make any sense. Count less than is equal to position POS. Yes, this variable is fine. Count less than is equal to position. CN is equal to CN of next. Count plus is equal to 1. It is going to 5. 1, 2, 3, 4, 5. Okay. Yes. Now I understood. It was going till last actually. Okay, let me tell you this again. What's happening was actually here this was equal to was there, and now when it is equal to, so what it was doing is for the first tense it was here, okay, and when it comes here it was in the value was no this value become 2. Here this value become 3. Here this value became 4. And then here means this was here, and it was equal to was given. So it was going till over here, and after that, it was not getting anything. Because of that, it was
Okay.
giving error. Okay, so ultimately, what we have to do at third position. Okay, so 55 third. Okay, so that is at second position. So what we have to do is we have to write it as position minus 1. Then only it will do at third. Okay, so now let's say 4 and 34 I am inserting. Now you can see this is coming at this place. Okay,
Okay.
34, 34 two times. Understood?
Makes sense. Yeah.
Yeah, that was a logical error. Because of that, it was not able to identify those things. Okay, so this will come by practice. You have to identify where something is going wrong because of which you are not getting the desired result that you want. Okay.
Okay.
Okay, so like this, you can insert a value at certain position, and now you can move. You can try it for adding a new element at the last. You can try that. Then after that, you can try the removing elements. Okay.
Yeah.
Will you be able to do that?
Yes.
Just try with those codes and make everything in function so that at last we'll make a one function together in order to execute everything one by one.
Okay.
Okay, so now that's how you will be able to modularize your code and you will be able to use that code anywhere else also. Okay.
Yeah.
Okay. So just tell me, Aditya, are you able?